Welcome back to the video series on integration and differential equations. In today's video, we're going to do some more practice with inverse trig forms. Here are the two key formulas that we saw in our previous video. In this video, we're going to do two more examples to practice these formulas. First example, let's integrate x dx over root 9 minus x to the fourth. Well, since we're seeing the square root in the denominator, that suggests it's probably going to be the arcsine form. Let's see if we can write the denominator as the square root of a squared minus u squared. So let's recopy this integral. And under the root, we've got 3 squared minus, well, x to the fourth can be written as x squared squared. Remember that when you raise an exponent to another exponent, the exponents are multiplying. So we're actually looking at this exponent as 2 times 2, and that's how we're getting the exponent 4 that we're seeing in that original square root there. Okay, so with that, we can try substitution. Let's sub u equal x squared, since that's the quantity that's being squared here in our integral. That makes du equal to 2x dx. And if we take a look back at our last step here, we've taken care of the square root. What we've got left in the denominator is x dx. So x dx is the expression that we'd like to solve for, and we can get that by dividing by 2. So du over 2 is another way of writing x dx. Now we can sub in, so that numerator is going to get replaced with du over 2. I'll just put the half out in front of the integral. In the denominator, we've got the square root of 3 squared minus u squared. So that now exactly matches our arcsine form. Applying the formula, we're getting 1/2 arcsine of u over 3 plus a constant. And to get our final answer, we just need to go back to our original variable. So u in this problem was x squared. And if we like, we can put brackets around that just to make it a little bit more legible. So final answer, 1/2 arcsine of x squared over 3 plus a constant. Here I've recopied the arctan formula, and let's try one more practice example. First thing we'll want to do here is rewrite the denominator. And for the arctan form, you want your denominator to look like a squared plus u squared. Okay, now at first glance it might not be obvious how to rewrite this as a sum of squares. What we need to do is think back to a special technique called completing the square. We would like to take this denominator, this x squared minus 8x plus 41, and we'd like to rewrite it as a squared plus u squared. So first step to doing that is we're going to look at the coefficient of x, and we're going to divide that coefficient by 2. So right now if we look at the coefficient of x, it's -8. If we divide that by 2, we get -4. Alright, so what that tells us, it tells us the first step in completing the square. So we're going to take our polynomial here, and we're going to write this as x minus 4 all squared plus something or other. So where did this -4 come from? That was just the number that we calculated at the top here. We took the coefficient of x, we divided it by 2, and that's the number that goes in the brackets with the x. So let's convince ourselves that this step is correct. So if we look at this expression here, if we were to expand it out, it would give us x squared minus 8x plus 16 plus question mark. So what's going on here is that the x squared coefficient is correct, the x coefficient is correct, but the constant is not yet correct. That's why we need the question mark on here. We're going to have to adjust that constant so that it's equal to what's on the left-hand side. So by doing this trick of taking the coefficient of x, dividing it by 2, you're making sure that your x squared and your x terms come out correctly, but your constant still needs to be adjusted. Alright, so let's recopy this. We've got x minus 4 all squared, and we're going to now think about our constant. So constant on the left side is 41. On the right side, remember when we expand this out, we're really thinking of this constant as being 16. So 16 plus something is going to give us 41. The correct number to have on the right side would be 25. Okay, so now overall we've got 16 plus 25, which gives us 41. So I'm going to put a check mark here. Yes, this is correct. And to write it in the fully completed version, let's say this is x minus 4 all squared plus 5 squared. Great. So that is completing the square done. With that done, we can go back to our integral and rewrite it. So we've got the integral of dx over, now in the denominator, we're going to write this version here that we just calculated. To make it exactly match the arctan form, you probably would prefer to write the constant first. So let's write the 5 squared first and then say plus x minus 4 all squared. So we're using the completed square version of our polynomial, and now this exactly matches our arctan formula. Okay, so we can go ahead and make a substitution. Let's sub u equal x minus 4. That makes du equal to dx, and we're ready to go back up to our integral. So rewriting our integral, dx can be replaced with du, and the denominator can be rewritten 5 squared plus u squared. So that is exactly the arctan formula that we've got at the top of the page here. So applying the formula, we're getting 1/5 arctan of u over 5 plus a constant. And for our final answer, let's just put that back in terms of x. So 1/5 arctan of u was x minus 4. So we've got x minus 4 over 5. I put brackets here just to make this a little bit easier to read, a little bit more clear to read, and then we've got our constant on the end there. So overall 1/5 arctan of x minus 4 all over 5 plus a constant. So there we go, we've had a bit more practice with the arcsine and arctan forms. See you in the next video.